Okay, so logarithms. Before we start that, I want to remind you the inverse functions. Let's say you have y equals 3x minus 1. If you want to write the inverse of this function, that's what we were doing, right? So we substitute x for y and y for x. And then we isolate y from here. So we get x plus 1 over 3 equals y. So this would be the inverse function. Okay? That's how we were doing it. How about if we apply the same thing here? Let's say we have an exponential function. Y equals a to the power of x. And you want to write the inverse function from this. So what do? You substitute x for y, y for x. So that's what we get. So this is the exponential form of the inverse function. But here we were able to isolate y, correct? But when you look at this, can you isolate y? We don't know how to, right? So actually mathematicians therefore came up with the logarithm. Okay, so they said if we isolate y from here, which is as you see the exponent, okay, if we isolate it, we say y equals logarithm base a of x. Okay, that's what actually, as you see, this exponent is now as y. And then if you compare these two, exponential form of the inverse function and logarithmic form of the inverse function, so base of the exponent becomes base of the logarithm, okay, and then the other two switches sides. So now y is on the left side and x is on the right side. So this logarithm means you are actually getting the exponent for that exponential function. Okay. So we can look at this shortcuts. If you have logarithm base a of x, that is equal to x. Okay, so let's say if you have logarithm base 2 of 2, okay, that is equal to, because this is power of 1, so that is equal to 1. Or if you have log base 3 of 3, that is equal to 1. If you have log base 5 square, then the answer is 2. Okay, as long as these two are matches, the base of the logarithm and base of this exponent matches, the exponent becomes the value of that logarithm. Okay. Another one, we can look at this later. Okay. So let's look at example 1. So we are doing evaluating the logarithms. So it says, the question says, express in logarithmic form. So they are giving you the exponential form. They're asking you to represent it with the logarithmic form. Right? So they are giving you the exponential form. You're going to represent it with the logarithmic form. So what did we say? Base of the exponent becomes base of the logarithm. So base of the exponent is b. So I'm going to make it base of the logarithm. Then the other two values changes sides, switches side. So then the exponent becomes here, like you put the exponent here on the left, and now m goes inside of the logarithm. Okay, these two represent exactly the same thing. One is exponential form, the other one is logarithmic form. Let's do it for part B. Base of the exponent is 4, so we're going to make it base of the logarithm. The other two values switches sides, so 64 goes here and 3 goes there. When I explain this shortcut, when evaluating, this is what I said, right? If the base of the logarithm and then base of this exponent matches, then the exponent becomes the answer or the value of that logarithm. So actually, if you look at this example, log base 4, 64 can be written as 4 cube. So again, so the base of the logarithm is same as the base of this exponent, then the exponent is the value of that logarithm. So let's look at C. Base of the exponent is 10. So it is on the right, so I'm going to put the logarithm on the right, not to get confused, right? You can do the same thing. If the exponent is on the right, keep the logarithm on the right. If the exponent is on the left, keep the logarithm on the left, not to get confused. So then we put this, the other two values switches sides, so -2 and this is 0.01. okay, again I can do this, right? I can write 0.01 as 10 to the power of -2. 0.01 is 10 to the power of -2. So therefore the value, or like if you need to evaluate this logarithm, it gives you -2. Another thing, if the base is 10, it is not written. Okay, actually I can just write log 10 to the power of -2, or if I go back to this original question, I can say logarithm 0.01 equals -2. Again, if the base is 10, we don't write. So one more thing about that base 10. If you look at your calculator, okay, you see one logarithm button. The base is 10 for this, okay, and you only have logarithm with base 10 in your calculator. You don't have base 2, you don't have base 5, but only base 10. Actually, you have one more line. The base, it is also a logarithmic function, okay. The base is a special number, we call it number E, or Euler's number, but if you take calculus, you are going to learn about it, but not at this level. So you just need to know that in your calculator, the logarithm button has base 10, okay. Therefore it is not written there as well. Alright, let's continue. We're gonna do the same thing here. The base of the exponent is 9, so we're gonna make it base of the logarithm, and other two switches side, 1/2, and this one is 3. Okay, actually we already answered it here, but this is just extra work to show you how we evaluate the logarithms. Again, so logarithm base 9, 3, as you know, can be written as square root of 9, correct? 3 is square root of 9, so then square root of 9 can be written as 9 to the power of 1/2 with rational exponent. So then the answer, of course, is 1/2. Okay, now let's look at example 2. This time they are giving you the logarithmic form, and you're going to put it in exponential form. So we are doing kind of the opposite, right? So we are going to take the base of the logarithm, make it base of the exponent, other two values switches side. So 5 cube equals 125. Same thing here. This time logarithm is on the right, so I'm gonna write my put my exponent on the right as well. So base is 2, so 2 to the power of, so other two values change side. -5 equals 1/32. So next one, base of the logarithm is p. So p is going to be base of the exponent, other two switches side. So p to the power of z equals w. Last one. What is the base for the last one? 10. We don't see it, right? We don't see the base. It means it is 10. So then the base of the exponent is gonna be 10 as well. Other two values change side. 1 over n goes here, and 1 over r becomes the exponent. Next example, just to find the location of your log button in your calculator, so you can take it out. Okay, so log 17. Okay, so base 10, as you see, log 17, 1.23. It says keep 3 decimals, so 1.230. Let's look at the other one. Log 0.00123. We get negative 2.91. Negative 2.91. 3 decimals. Can you also try log negative 5? Check what you get. Math error? Yes. So you cannot have negative numbers inside that logarithm. Okay? Why? First of all, logarithmic functions, so exponential functions, for the exponential functions, base is always a positive number. Okay? It is always positive. Let's say you have 2 to the power of x, or 3 to the power of x, or 1 over 5 to the power of x. But as you see, the base is always a positive number. Yes, you may have this, right? So negative 2 to the power of x, which is fine. But for this one, base is positive 2, but then there is a reflection, or at the end, it is multiplied by negative 2. So you wouldn't see any exponential function with negative base, something like this, negative 2 to the power of x, right? So if the base is positive, and it doesn't matter what exponent you have, will this ever be a negative value? Let's say you substitute 3 to the power of 2, right? You get a positive value. It doesn't matter, let's say you have 3 to the power of negative 3. So that gives you 1 over 27, alright? But you end up with always with a positive value. So inside of the logarithm, that value is what you get from here. That is the reason it cannot be a negative value. Okay, I mean, yeah, so you get math error, so it is undefined. Now we are going to do some evaluation, and we are going to use this shortcut to do that. Okay, so I mean, two ways of doing it. Let's apply both. One is going to be the shortcut, the other one switching it into exponential form. Yeah, let's do both of them. So let's say let's use switching it into exponential form. Then this is what we do. So we say we want to find this out. Let's call it x. If you put it in exponential form, what do you get? So base of the logarithm is 2. So base of the exponent is 2. Other 2 switch aside. 2 to the power of x equals 1 over 32. And in grade 11, you learned how to solve exponential equations. Okay? So you try to write both sides with the same base. So in this case, you can write both sides with 2, with base 2. So 2 to the power of x, 1 over 32. 32 is 2 to the power of 5. So you have 1 over 2 to the power of 5. That gives you 2 to the power of negative 5. Okay, so 2 to the power of negative 5. Now you can see that x is negative 5. So this logarithm equals negative 5 here. Second method, the shortcut. So log 2 base 2. So now to be able to use the shortcut, whatever you have inside that logarithm, you want to write it with the base same as the logarithm. Okay, so then 2. Again, you need to write 1 over 32 with base 2. Then the answer is the exponent, right? Negative 5. Let's look at the next one. So we have logarithm cube root of 10,000. So method 1, put it in exponential form. We call this x. The base you don't see means it is 10. So you get 10 to the power of x equals 10,000 to the power of, we get rid of that radical, right? So you can write this with a rational exponent. You can write 1 over 3 to the power of 1 over 3. Then 10,000 can be written as 10 to the power of, count the zeros, right? 1, 2, 3, 4. So that gives you 10 to the power of 4. So 10 to the power of 4 to the power of 1 over 3. So 10 to the power of x equals 10 to the power of 4 over 3, because you have a power of a power, then you multiply the powers, then you get x equals 4 over 3. Okay, so you know that this is 4 over 3. If you use the shortcut, so you say log, base is 10, we know, 10 to the power of, so you are going to write cube root of 10,000 with base 10. We already did that here, right? We said it is 10 to the power of 4 over 3. Therefore, the answer is the exponent, which is 4 over 3. Next one, log base 2 of negative 5. Again, you can't have a negative number inside the log, so that is undefined. Let's look at the next one. So first method, we are going to say this is equal to x and put it in exponential form. So 1 over 2 to the power of x equals 4. Now you write both sides with the same base. So that could be 2. 2 to the power of negative 1 times x. So that gives you 2 to the power of negative x. And the right side is 2 to the power of 2. Then you get negative x equals 2. Then x equals negative 2. You could also write both sides with 1 over 2. That is also fine. Okay? That is fine. So you could also say 1 over 2 to the power of x. This time write 4 as a power of 1 over 2. So you would get 1 over 2 to the power of negative 2. So again, you get x equals negative 2. Using the shortcut, again you would write 4 with base 1 over 2. That would give you 1 over 2 to the power of negative 2. The answer is negative 2. Next one. Base is 1 over 9. So we are going to say this is equal to x. 1 over 9 to the power of x equals 1 over 3. Write both sides with the same base. So you can either say 1 over 9 to the power of x equals 1 over 3 can be written as square root of 1 over 9, which is 1 over 9 to the power of 1 over 2. 1 over 9 to the power of 1 over 2. This means square root of 1 over 9, which is 1 over 3. Or you could say that this left side is 1 over 3 square and get the x from there. But we see that x is equal to 1 over 2 from here. Okay, another way, let me put this here. You can say 1 over 9 is 1 over 3 square. Okay, then you say 2x equals 1. Then you go also get x equals 1 over 2. Second way or shortcut, logarithm 1 over 9, 1 over 3. Again, we said that can be written as 1 over 9 to the power of 1 over 2. Therefore, the answer is the exponent. Logarithm 100 to the power of 8. As you see, there's no number for the base. That must be 10. So that's equal to x. Okay, put it in the exponential form. 10 to the power of x equals 100 to the power of 8. 10 to the power of x equals 100 is 10 square. You have a power of a power, you multiply the powers, so this gives you 10 to the power of x equals 10 to the power of 16. So x equals 16. If you use the shortcut, logarithm, base is 10, 100 to the power of 8 is 10 to the power of 16, and then that gives you 16. Next one is another shortcut that we use. Okay, if you have 7 to the power of, and that shortcut is here, I told you that I would come back to it. If you have a to the power of logarithm base a of x, that results in x. Let's say you have 5 to the power of log base 5 3, base 5 of 3, the answer is 3. Okay, so where this rule is coming from, let's say you have this 5 log 5 x. So we want to calculate this, so let me call it y. If I put this in logarithmic form, what do you get? Log base 5, other two switches sides, y equals log base 5x. Okay, I just put this in logarithmic form. Now log 5 log base 5 looks like that y and x, if these two sides equal to each other, they must be equal. So then y is x. That's how we can prove that this shortcut is correct. Having said that, then if you have 7 to the power of log base 7 of x, the answer is going to be x. If you have 6 to the power of log base 6 36, the answer is going to be 36. So the next one is a little bit complicated, because as you see, the base of this exponent and base of that logarithm do not match. One is 8, one is 16. Okay, so for now you don't know how to change the base of the logarithm, so you cannot change that. But actually we can work and try to change this base of the exponent so that we can use this shortcut to answer this question. This is how we do it. Again, I cannot change the base of the logarithm for now, right? So therefore I want to change this exponent. So means I need to write 16 with base 8. So how can I do that? So I want to write 16 with base 8 so that these two are these two match. Okay, so I'm going to say 16 equals 8 to the power of x. I want to know that. So 16 equals 2 to the power of 4. 8 to the power of x equals 8 is 2 to the power of 3 to the power of x, so that gives you 2 to the power of 3x. So the bases are the same, then exponents must be the same. So so 4 equals 3x. Isolate x from here, you get 4 over 3. This is what it means. So 16 equals 8 to the power of 4 over 3x. So I was able to write 16 with base 8. So I can replace this 16 by that. So 8 to the power of 4 over 3. Oh, sorry, x is that anyway. 4 over 3. X is not there. 16 equals 8 to the power of 4 over 3. And it should be true. You learned how to work this out in grade 11. So this is telling you that take the cube root of 8, then take the power of that value, right? Cube root of 8 is 2. Then you need to take the power of 4, gives you 16. Okay, so now I replace 16 by 8 to the power of 4 over 3. And then we have log base 8 of 125. So now you have power of a power. You multiply the powers. You get 4 over 3 times log base 8 of 15 here. Well, actually now we're going to use one of these logarithmic rules to be able to answer this question. Here we see some rules here, right? There's a product rule, there's a quotient rule, this is one power rule. Actually we kind of use that for this shortcut, kind of. Okay, so if you have log base a of x, so with any base x to the power of r, that is equal to r times logarithm base a of x. So you kind of take the exponent, drop it to the front as a coefficient. Okay, so take the exponent, drop it. So let's say you have log base 3 to the power of 5. So this gives you 5 times log base 2 of 3. Okay, you just take the exponent, drop it to the front. Okay, so then how about if we use this rule but backwards? Then if you have r times logarithm base a of x, now you can take that number, put it in as an exponent. Okay, just going backwards. Then I'm going to take this 4 over 3 and put it inside as an exponent. Now you need to calculate what is 125 to the power of 4 over 3. So this is like you are taking the cube root of 125, then taking the power of 4. Cube root of 125 is 5. So 5 to the power of 4 is 625. So we get here 8 to the power of logarithm base 8 of 625. Now finally we can apply the shortcut. This gives you 625.